Okay, so question number 7 starts with the expected value. So expected value, we are just going to multiply these. So that is going to be just a 1.02. I'm going to ignore the 0 plus a 2 times 0.1 plus a 4 times 0.3 and a 5 0.2, and our calculation for that one, please, comes out as 2.6. Okay, next, expected value of s squared, extra row on the column, or s squared here if you like, 0, 1, 4, 1625. So we can copy this one again, 1 times 0.2, then we can do a 4 0.1, a 16 0.3, a 25 0.2. Let's do it consistently. And that should give me 10.4. So the variance, of course, the variance is going to come next. So the variance is going to be, variance of s is going to be the expected value of s squared, which we know, minus the expected value of s all squared. So we just said that that was 10.4, take away 2.6. So if you take away 3, you get 7.4, then add it back, you get 7.8. Have I done something there? Oh, no, sorry, I'm just checking. Yes, my answer sounds a bit weird there. Sorry, I forgot to square it. So take my calculator out, 10.4 minus the answer. So 91 over 25, which is 3.64 exactly. Okay, so that's the nice bit. Right, what are we doing next? Find the expected value of 5s minus 3. So these are some coding ones. So the quickest way is for me to identify that this is the same as 5 expected value of s minus 3. So it's 5 times 2.6. Take away 3, which is 10. The variance here, so we're multiplying by 5, so it's going to be the 5 squared of the expected value of s. Okay, which is just 91. Okay, hope everybody's all right with those so far. What's this one here? So this is an example where maybe simplifying the inequality makes sense. So if you take away an s from both sides, you get... Do I want to do that? Yeah, I suppose so. So 4s is greater than 6. So when is s greater than 1.5? So when's s greater than 1.5? Well, the possibilities that I'm interested in then are 2, 4, and 5. So that is just 0.1 plus 0.3 plus 0.2, which is 0.6. Okay, done. Let's do the sort of harder ones. The spinner is spun twice. The score from the first is S1, so yeah, S1 typically means the first time you do something. The score from the second is S2, the second time you do something. They're independent, yeah. X is what you call it when you do S1 times S2. Show that the probability of the first one being 1, well, that's 0.2. And the score from them multiplied being less than 5 altogether is 0.16. So we need to think about the different possibilities. We're talking about getting a 1 first, and we know that that's 0.2. So maybe we could do something like that. Let's think. So we're doing the same thing again now, and we're going to multiply it by, we're going to multiply the 1 by whatever comes next, and we're interested in when it's less than 5. So, is that what we're doing? We'll just double check. So the 0 counts, doesn't it? 1 times 0. The 1 counts, the 2 counts, even the 4 counts. The only thing that doesn't count is the 0.2. So yeah, I could just add them all together, but just to make you think about this a little bit more, I'm kind of thinking here about not 5. So what's the probability of not 5? Well, that's going to be 0.8, isn't it? So can you see that's where the answer is coming from? So that question looks quite intimidating, but the S1 equals 1 is just saying you get a 1 on the first one, and the next one is such that when you multiply them, the product of those numbers is less than 5. It's actually not as bad as it first looks, all right? So 0.2 times 0.8 equals 0.16. I'd probably add a bit more fluff onto this, which is, I would say something like, it's the probability of, this statement would be correct still, wouldn't it? That S is equal to 1, that S is equal to 1. I could do comma for the next one. I could do S1. There's so many things I could write. Yeah, let's do that. And S2 is not equal to 5. That's a correct statement. So finally, find the probability that the product from 2, because that's what X is defined as, is less than 5. So again, let's go back to this one here and let's think about just how many there are, because we might not need to work them all out. So anything with a 0 counts. Not anything with a 1 counts. I'm just trying to think now. Is it easier for me to list them out? It's pretty close. I think I'm going to list them out. So I'm going to say, I'm going to go into Big Pen now. So I'm going to say that I want the probability of S1 being equal to 0. And that's fine on its own, because I'm not really interested in what happens next. I know that's fine on its own. So that's just a 0.2. So I want the probability that the first one is a 1 multiplied by the probability that the second one is what? It's not equal to 5. As long as it's not 5, I don't mind. So what's that? That's 0.2 times 0.8. We just did that, didn't we? Yeah, so I suppose it's meant to help us out, that idea. So we want that, we want that. What else do we want? There'll be a few more. So S2 being equal to 2. And then what does the next one have to be? A 0 is fine, a 1 is fine, a 2 is fine, and that's it. So that's 1. So multiplied by the probability that S2, and this is what they said in the mark scheme, which is quite a good way of doing it, is less than or equal to 2. So that would be 0.1 for the first one, and then this is the 0.2, the 0.2, the 0.1, so that's 0.5 altogether, isn't it? Couple more. So the probability that the first result is equal to a 4. What can that go with? That can go with the probability that the second one is less than or equal to a 1, which is 0.3 times 0.4. And if you have a 5, you have to have a 0. So if that's a 5, this is the probability that S2 has to be equal to a 0, isn't it? Which is, don't just write 0, that would mean you've switched your brain off at that point. So S2 equals 0 is 0.2. So I would like now to find the sum of all of those probabilities there. Yes, I think that's correct, isn't it? I'm just trying to find if I haven't said anything. So the probability of x being less than or equal to 5. Am I happy with all those? So 4 and a 1 and 0, 5 and a 0. A 2 and a 2 is the maximum. A 1 and not a 5. Yeah. So you should just be adding all of those ones together. And that's how you would answer question 7.